Hello and welcome. My name is Md.Mubtasim Fuad,
And this is me, Afsara Afrose Orna.
and today we want to go over a key search algorithm in graph theory, path first search or BFS. Suppose you are given a graph with the starting vertex and asked the question of find the shortest path from the vertex to find other vertex in the graph. The BFS algorithm allows you to answer this question. So in the video we go over the definition of path first search and its time complexity and understanding the path first search algorithm with an example. Alongside the depth first search, the path first search algorithm is another one of those fundamental search algorithms used to explore nodes and edges of a graph. Path first search algorithm is a graph traversing technique where you select a random initial node as a source node and start traversing the graph level-wise. In such a way, all the nodes and their respective children nodes are visited and explored. It runs in a time complexity of peak O of V plus E, that is vertices plus edges, and is often used as a building block in other algorithms. It differs from a depth-first search in the way that it explores the graph. The breadth-first search algorithm is particularly useful for one thing, finding the shortest path on an unweighted graph. In the next animation, we will rely on a queue that will help us track which node we should visit next. Upon reaching a new node, the algorithm adds it to the queue to visit it later. The queue data structure works like a real-world queue such as a waiting line in a restaurant. People can either enter the waiting line that is gate enqueued or gate seated DQ.
Let's see an example of breadth first search. As we know, a BFS starts at some arbitrary node of graph that we can say source node and explores at neighbors node first before moving to the next level neighbors. In a sense, a breadth first search explores nodes in layer wise. So if we start breadth first search as 0, we would visit 0 first, then visit all the zeros neighbor, and that is 9, 7 and 11. Then we would visit all zeros neighbors, the nodes in yellow, before moving on the next level of nodes. Then we would visit all their neighbors and so on. So as we saw, a breadth first search explores a graph in a layer wise. It does this by maintaining a queue of which node it should visit next. This is most easily seen with an example. Let's begin a breadth first search a node 0 once more. So let's add 0 to the queue on left. I would denote the correct node in the red, so 0 is the correct node. And we want to explore all zeros unvisited neighbors and add them to the queue. So we will add 9 to the queue, 7 to the queue, and 11 to the queue. Now we can see 0 has no more unvisited neighbors. So we dequeue the node 0. That is, the color is gray. Then we move on 9 in the next node of queue. We add all the 9's unvisited neighbors, the queue. So that is 10 and 8. There are no more neighbors of 9 to visit. Then we move to the 7, moves to the next node of queue, and which is 7. Then we add all n's unvisited neighbors to the queue. At this point, we try and visited node 11, but it is already in the queue, so we don't need to add again. So we can skip it. Then we will add 6 to the queue and 3 to the queue. Then this process goes on and on until we learn out of the nodes in the queue. Let's see the animation play, what happened actually. So when the queue is empty, all the nodes are visited. and that's the process how we do a breadth first search actually. And that is for breadth first search video. Thanks for watching.